Hello learners. We are on video number 4 of vertical projectile motion. We are sketching the graph, position time graph, velocity time graph, and acceleration time graph for the bouncing objects. Okay, so remember we have two definitions that we need to take care of. So we have projectile, an object which has been given an initial velocity and then it moves under the influence of gravitational force only. Then we have free fall motion, during which the only force acting on an object is the gravitational force. Okay, so this is the object that is thrown vertically downwards, then it bounces back. Now let's assume that the time here is okay. Before that, so is position A is our A, this is our B, this is our C. Let's say this one is D. So the time, that is delta T between BC, let's assume that is 0.3 seconds. Okay, now we need to have the time from A to B, the time from C to D. Okay, so we are going to calculate that, hoping that is clear. Now this one is just fixed. Now at point A, here we have the height. As we said on the previous video, this is 50. This one is the ground. The height here is 0 meters. Okay, so we need, okay, let's come to here, the maximum point after bouncing. So we need, the height here is 10 meters, right? All right, so if you notice here, we have 3 points that are important in position time graph, but we need time. Here the time is 0 seconds. So on the previous video we calculated the time here at B was 2.33, but we need the time here, seconds. Here we need the time here. Now we are going to calculate the time at D. All right, now let's collect the data. The focus is between C and D, and remember that there is this portion which is 0.3, but we need this portion. Then we add all the time. From here to here is 0, then from here to here is 0.3, then from here to here is what we are going to calculate now. Okay, let's collect the data. The data in this path, that is CD. In path CD, we want to know the time at CD. The data in path CD, oh, remember this time is for B. Let me write it now. Then we'll need the time for what? For C. The time for C is 2.33 plus 0.3, which is equal to 2.63 seconds. Now we are looking for the time at D. Okay, so the data between B and C is, we have from here to here, we're looking for delta T. We're looking for delta T. We have only one velocity here, velocity which is at maximum point, which is equal to 0. Okay, now if we say 0 is the initial velocity, which means we are talking about this side, the time here is the same as time here, né? So delta y is below the initial velocity, so it's 10 downwards, right? Then we have acceleration. Acceleration is 9,8 downwards. So we can use the third formula, which says delta y is equal to the initial velocity delta t plus 1 over 2a delta t squared. Now delta y is then everything is down. We said take down as positive, so take down as positive in this case. Down is positive, down is positive. So here the displacement is positive, then the initial velocity in this case is 0 times delta t plus 1 over 2 times 9,8 times delta t squared. So this one is equal to 0. Then we transpose this one. So we have there's no need to transpose since we have two terms. There's no need to transpose. So we have 10 here, which is equal to, this one is 0, then this one is 4,9 delta t squared. Then we can just divide by 4,9 both sides. 4,9, 4,9. So we have delta t squared here, then 10 divided by 4,9, 4,9. So it's 2,04. Then square root, so it's plus or minus here. Therefore, delta t is always the positive one. Is the answer is here 1,42, 1,42 or 43. That's 43 seconds, the positive one, right? So the time from here to here is 1,43. Hoping that is correct. Then we are going to add from this one to get the time here. So the time here is 2,63 plus that 1,43. Therefore the time is plus 2,63. the time is 3,82 second. Okay, so everything now is fine. All right, now we have all the time, all the displacements. Now we need to draw the graph. Remember, we have point A, we have point B, we have point C, we have point D. The time here is 0. The time here is 2,33. The time at C is 2,63. That is 2,33 plus 0,3. Because from here to here is 0,3. So we add from that one 0,3. Now we are going to add this one this time, and this time, and this time to get the time at D. So the time at D is 3,82 seconds, right? Then the displacement here, the distance, the height in fact is 50 meters here. The height here is 0 meters. That is at B, the height is 0 meters. At B is 0. At C is 0 meters. Then here is 10 meters. So we can draw the position time graph with this information. Okay, position time graph. I'll just draw it here. Or let me just wrap here. Good. Then let's draw the position time graph. Position time graph. So we have the position on the y-axis and the time delta t on the x-axis. So here is the position in meters. Okay, this is the position in meters. Okay, now let's write the positions that we have with 0, 10, 50. So this is 0, this is 10 for example, then this one is 50. This is what we have. Now this is very easy. The ball was dropped vertically downwards, so that is the first one from 50 to 0. Then it takes some time, then it bounces to the maximum height, that is our 10. Done. So we need the time here. The time here is 2,33. 2,33 plus 0,3 is 2,63 plus 1,3, then here is 3,82. 3,82. That is the position time graph for the bouncing object. Now let's go to the velocity time graph. Alright, when we draw the velocity time graph, in each point we need the velocity and time. That is the first point, we have the initial velocity and the time is 0 seconds. Then at B we have only time that we calculated on the first graph, that is position time graph. And this is C, we have the time. This is D, we have the time, which means we need to calculate the speed here, the speed here, and the speed here. I will calculate only the speed here, then others I will just show you the value. Okay, let's calculate the speed between at C, because we know the speed here. Okay, so we are talking about CD here, CD. So the initial velocity is the velocity at C, that is what we are looking for. Then at D, that is our final velocity, which is 0. Then we have the height, that is our dy, which is 10. Now if you can look here, this ball is going up, which means this 10 is above the starting point, which means this 10 now is upwards, 10 meters upwards. Then the acceleration is 9,8 downwards. Okay, we want the initial velocity, so we are going to use vf square, which is equal to vi square plus 2a delta y. So final velocity is 0. The initial velocity is what we are looking for, plus 2. Oh, now we have to choose the direction. Okay, we said take it down as positive, which means this one is negative, so the acceleration is still positive. 9,8 times dy is negative 10. Okay, so we have 0, which is equal to initial velocity square minus positive times negative is negative. 2 times 9.8, it's 19.6 times 10, it's 196. Then we transpose, so the sign will change. We have positive 196, which is equal to v initial square, then the square root, so it's plus or minus. So square root of 190, that is v initial, this cancels that. Then of 196, it's 14. Then since it is going up, that will be the negative one. We'll choose the negative one. So therefore initial velocity, that is the velocity, that is velocity at C, is equal to 14 meters per second upwards. Okay, so we have the velocity at C. So we need the velocity at B. I'll just write the value. The velocity at C is 14. Let me just say negative 14 meters per second, right? So the velocity at B is 32,86. Now, since we are drawing the velocity time graph, so we need the coordinates. Let's just list the coordinates. Let me wrap everything here. So we have point A. So the coordinates at point A is, remember, we start with T, that is X, then V, that is Y. So the time here is 0. The velocity is 10, which is positive because we take down as positive. That is the first point. Then the second point is B. The time is 2,33 is to 32,86, right? Then the second point is this one, C. The time is 2,63 is to minus 14, right? Why minus 14? Because it is going up. We take down as positive, which means up is negative. Then we have point D, the last point. The time here is 3,82, whereas the speed there is 0. That is the maximum point. So we have the coordinates. Now it's time to plot the graph. Now what is important when you have the coordinates is to write x values on the x-axis and y values on the y-axis. So we have 1, 2, 3, 4. This is the first one, 0. Then the second one is 2,3. So we say 2,3, 2,33. Then the third one is 2,63. So the last one is, let me just write it here, is 3,82. Then on the y side we have 0. This is 0. Then we have 10. This is 10. Then we have 14. This is 14, right? Then we have 32. Let me just write here, no problem, 32,2,86. Then I copy this. I have minus 10 here, I have minus 14 here, then I have minus 32,86. Now let's plot. The first point is 0, x is 0, this is 0. Then y is 10, so this is 10. X is 3,33, this is x 2,33. Then y is here. Okay. Then another point, x is 2,3 or 63. This is x. Then y is negative 14. This is negative 14 somewhere here. That is from here to here. Then the last one is x is this one. Then y is 0. So y is 0 here. So when we plot, we just join like this, done. Then join like that, done. So if you want to join this, you can just use the broken lines. Right? The broken lines. Alright, then we're done. That is the velocity time graph. Remember, here we have delta t in seconds, then here we have v in meters per second. Then we're done. So another thing that you need when the object is bouncing is that there is a collision between the ball and the floor or the ground. Now if you can look here, this object is from a height of 50, then bounces to a height of 10, which means the collision here is inelastic collision. It loses energy when it bounces here. It loses energy when it was in contact with the ground here. Okay. Now, if you can look at the speed, it was having 32,86 meters per second here, but the speed decreases to 14, which means it lost the energy. Therefore, the collision is inelastic collision. Let's go to the acceleration time graph. So acceleration time graph is very easy because acceleration is constant. So we have 9,8 here, we have minus 9,8. Then we have so many times, we have 2,33, 2,63, 3,82. This is the time in seconds. This is the acceleration in meters per square second. Now what is happening here is that the ball is on free fall between A and B and between C and D. The ball here is not on free fall. There is another force exerted by the ground on the ball here, which means the acceleration there is not 9.8. And the acceleration is changing direction, which means remember, let's take down as positive. This one will be negative, okay, but not 9.8. So you are going to draw a graph like this. Then between 2,3 and 2,6, the ball was in contact with the ground. So between this and this, still the acceleration is 9,8. But here the acceleration is not 9,8 during contact time. So you can draw it here, but not minus 9.8. It's less than that. Okay, then we are done. That is the graphs of a bouncing object. Thank you.